Okay, in this video we'll be explaining how to replace a disk in your RAID array and rebuild the array so that you can get back your redundancy and performance. And many years ago I had a problem where I was running an Intel chip and I didn't have my icon permanently displayed in my taskbar, and I didn't catch the pop-up showing that a disk was about to fail. And so it's always important that you have your RAID icon always in display in the corner so that you can see that there's a change, the color or whatever changes when an array goes critical. So in this case I'm running an AMD chip, and you can see that the RAIDXpert is green. All arrays are normal right now, but I'm going to show you how to replace a disk. So first thing I want to show you is when you double click on that and you log in, which if you have trouble logging in, I already explained how to fix that in the other video. But you can see here I have 6 disks, they're all 2 terabytes, and I'm running RAID10s, so I get half the space. And here there's the disk silos. You can see that this one copies that one, this one copies this one, and this one copies that one. And I have one disk that has a different serial number. It's a different model than all the other 5 disks. And I've been running it 24/7 for about 8 years now without any problems, but it's time to replace. So this is the one I'm going to swap out, and what you should do is take note of all the serial numbers because they're displayed on the drives, and then you'll know which one to swap out. And there are ways that you can swap out a disk without turning off your computer, and if you're a professional you may want to do it that way. You take a disk offline and then you do hot swaps, or I don't know actually how to do that. So for my case, replacing a disk once every bunch of years, I think it's better just to turn off your computer, do the swap, and then come back into Windows. The disk type I'll be using here are these 2 terabyte Hitachi drives. They are 0F12470s, and they cost about $40 used on Amazon, and they are enterprise disks, so they're quite loud. Sometimes they can wake you up at night when they're working, but they're robust and very cheap when you buy them. I think that they are just running a certain lifetime in data centers, and then they sell them online. Okay, so looking inside the computer, I have 2 propped up sideways just to help dissipate heat, and then on the bottom I have the 4 other drives. And just to point out, the one I'm going to be replacing is this one, and I know that because I wrote down the serial numbers, and right here you can find a listing of the serial numbers right on the drive, so it's very convenient and you always know which one you're dealing with. So I'm going to swap that out with this one. Okay, the disk is now in there, and the computer is going to boot now. Okay. Now look at this. Okay, so it says it's in critical mode and it detects a legacy drive, 2 terabytes, but we're not going to use that booting configuration to do this, because one of the great things about being able to rebuild an array is doing it in Windows and being able to use your computer while it's rebuilding. The process usually takes about 10 hours to rebuild one disk out of the 6, in my experience. Okay, almost in Windows now. Now watch what happens. It's going to tell us again there's something wrong. Okay, check out this pop-up. Event service. Array 1 has gone critical. Warning, a rebuild task has resumed and completed. I'm not sure what that's about, but usually it just says gone critical, and then there's a pop-up that says array 1 has gone critical, so we'll hit OK. And here's the icon. You can see I mentioned before that you want to have this in your taskbar at all times because you can see that red symbol on top of it and you're likely to notice that. So let's boot into there. Log in. Alright, and we see here the new drives in. We have all of these different drives. And over here you can see that this disk has been removed and it shows a second array possessing the other disk. That's not really important, but what we need to do is initialize this disk in order to allow it to be incorporated into the array. Okay? It says new right here instead of the type just being a disk. So it needs to be initialized. So what you do is you click on it and then go to initialize under the disk menu. And you can check off this new disk and then initialize. And it warns you it's going to erase anything that might have been on it, but that doesn't matter since it's a blank disk anyway. Now that's pretty much an instantaneous process, but now you can see that the fake array is now disappeared and the disk is no longer there, but it is able to be incorporated into the array now. So the way to do this is, what did we do? Oh yeah, you double click on the disk and it says there's 2 terabytes available. So we double click on that. And what I don't really understand is this assign as dedicated versus assign as global spare, because it's blocked out dedicated and I don't know why that is, but if you think about it, if you were running a data center as a professional, it would be nice to have global spares, because global means that it can be used at any time to rebuild a failed disk remotely on any array if you have multiple arrays running. So what you would do is have racks of disks, I think, where you would have some spares sitting there so you wouldn't actually have to go into the room to physically swap out disks. So I don't know why dedicated is not an option. I mean, maybe it's because I only have one array, so it doesn't matter, but what you do is confirm that as a global spare, and right then and there it will begin. You can see here a rebuild task has resumed. Now it's going to take about 10 hours and the progress is shown right here, 0%, but it is going to incorporate that disk into the array. Just a note, now that the rebuild is happening, I happen to notice that even though these are all the same models, there's one difference over here, and that is in this menu. You can see that my new disk has write-C in the feature line. That refers to write-back caching, and so if you go to disk and then properties, you can see all the disks here, and write-back cache is currently enabled on that disk. Now I'm going to check that box and I'm going to disable it, and I'll tell you why. There, now it's disabled. So write-back caching, from what I understand, essentially speeds up the write speed to the array because it sits in cache and then it can wait to be written to disk, if I'm understanding it correctly. And what that means is that if you don't have a UPS installed, so that if you have a power outage then you'll have continued power, then what can happen is a power outage would cause you to lose data, and so that's why I've disabled it. And you do take a fairly significant hit in performance. So I have run these in Crystal Disk Mark, and to compare, I don't really understand the specs, but I get you can see the read and write speeds here. This is with write back cache disabled, so that's the more sorry, this is with it enabled, it's faster, so I get a read of 338 megabytes a second, 250 on the write, and then various speeds for these different blocks, or whatever they are. But you can see they're significantly lower when I disable the write back cache. But this is the save option so that if the power goes out, then you don't lose anything. So I'm going to experiment and see if I can get by living with that. If not, I'll have to invest in a UPS. Okay, now the rebuild is finally done. I ended up turning on the write back cache in order for it to go in about 8 to 10 hours. And so now back at the home screen, everything's running fine. You can see that all the disks are there. One last thing, you can see under the GS or global spare that it says yes. You can, I don't think it matters, but if you double click on that, you can remove as global spare, and then now everything is the same in all columns and the array is running fine. And now I think I should just highlight all the disks and disable the write back cache just to be on the safe side, and we'll see how the performance is. And that's it.